decided to literally take integrate the caps into the waterproofing system, so they put these patches over and wet sealed the entire system. So again, short-term solution, probably worked for a while, but the impact down the road of, you know, when it goes the next time is huge. Otherwise, you know, you'll see filling gaskets at unit windows very often. Sometimes you'll see, you know, frames that are just field assembled and that kind of thing. Those frames have gaps, seal and fills, eventually, you know, along those interfaces as well. So those are very often what we're looking at. Rain screens are another new fad in the architectural industry. The idea, I think, is to basically be able to put the insulation envelope on the outside and just have the cladding be essentially decorative and you know, substantial weatherproofing to keep the rain off of what's actually keeping the building watertight. The biggest issue with this is that, again, you have one shot of getting it right. You know, when you construct it, before you put all this stuff over the top, you got to make sure that the flashings are correct and the interfaces are sealed, the flashings at window openings and those kind of things are done correctly. And then another little twist on that is that you have to have some level of knowledge about the wind pressures on the building, because these gaps are all left open, which means if you have the windward side of a building, it's actually driving water into there. So there are again times where you can have flashings and openings fail because they're just getting more than natural water falling out. You know, pressurized test building. Maintenance repair. So if we are having issues with our building, basically there's a cost to digging into it and figuring out what's going on. I show a bunch of different water testing things here. Sometimes, like this building, one of the biggest factors is that they had a test or two done before we were there and never could get it to leak. And one of the little tricks is that from an HVAC perspective, buildings are oftentimes negative pressure, right? So during the day, systems running, people are in there, water can be drawn into places where it doesn't otherwise go. So if you don't test it under those circumstances, you might not ever figure out what the problem is. So you see the louver here, in this case, it had nothing to do with the curtain wall. It was the fact that under HVAC load, water was being drawn into that louver, and it was actually inside the building where the problems were occurring. It wasn't leaking, holding water out. Sometimes you just have to tear things apart, figure out how they were constructed. In this case, we opened up a patch over the windows to figure out, you know, how this through-wall head flashing was installed. It's just the fact that there's a cost. Up in this corner, this was called Rylom tube tests. You can basically tell what kind of absorption rate the brick masonry has in itself, or what the mortar joint itself has. And so that's another way of figuring out, you know, where's the water actually sucking into the building. So you get right down to it. Repointing long-term fix for masonry. Once it gets to that point, there's discussion of how to quantify that, how to, does it make sense to do every joint, on a building when you get to that point because of the cost of staging, of, the trauma of getting there, as I said before. But oftentimes, I think we say, why would you ever cut out a perfectly good mortar joint? Because it's never going to be better than it is, if it's not failing now, why would you ever do that? So that becomes a case of how do you get a contractor to bid on something that is partial, and that's how you get it. Masonry restoration bidding has been an art form for years and never real apples to apples, just because of that.
Anyway, just to kind of make about
Yeah.
one point, especially if it's an older historic building, getting the masonry tested and knowing exactly the masonry type before you're.
For the mortar?
Yeah,
Yeah.
that's really important.
Yeah, especially historic buildings, incredibly important to try and go back and match the appearance of it as well as the physical characteristics of
I
it.
mean, because in terms of absorbing moisture as well as strength.
And
Same expansion rate.
And movement, yes,
Yeah.
exactly. Softer mortars are generally better. And
Yeah.
a lot of that is because natural mortar kind of went out of fashion at the turn of the last century. Turn to Portland, and that automatically boosts your hardness, your compressive strength. Throw-off flashings are incredibly important. And seldom in the past done right. I would say that in that 50s, 60s, 70s era into the 80s, they were oftentimes not installed at all. And as we move forward into thicker insulation requirements and, other things that require us to touch the building, again, very important, and we do a lot of this, which is basically either installing or raising, so basically picking out courses of brick masonry so that we can lift and get a proper seal. So when you do that, again, sealing the top edge of that through-wall flashing that comes out, doing corners properly, steps, if they exist in all very, very critical to not having that wall to roof interface leak down the road. I think patching materials generally have gotten much better in the last 10, 15 years. When you look at, exposed concrete, where you have those kind of things, even stone, limestone, granite, the epoxy repair materials, the additives to traditional masonry materials can do a good job. Another thing we oftentimes, this is just like the through-all issues, like what I dealt with in Honolulu. Once this is up there, no one wants to touch it again. But if you're going to redo the roof, and you're going to raise wall flashings and interfaces like that, you're going to have to touch it. So you can actually get into this, cut it, grind off, prepare, and patch that back in. We've had fairly good success with that, modifying those kind of things that weren't done correctly in construction, or you're needing to raise and redo based on insulation heights and things like that. Seal replacements, again, very common maintenance issue. Joint preparation is critical. Getting old seal and residue off of there. Priming or cleaning prior to this, because otherwise this happens. And you got a bead of brand new sealant that's a couple years old and it's already just adhesively failing off the surface. This was a mock-up at a project, so that wasn't a good sample. They were trying to display colors, but had some purpose issues as well. This one shows both adhesive and cohesive failure, so sometimes if the joint isn't constructed properly in terms of width and depth, it can simply split down the middle like that. And again, that's just good backer materials preparation of the joint ahead of time. I put this one in here that there are some newer technology sealants out there called hybrids. One of them, like silyl terminated polyether is one that we use oftentimes with EIFS projects. And that is a newer product that takes some of the characteristics of polyurethane as well as silicones. Yeah, it sort of mixes them in high-tech chemistry or whatever. So it's got applications in the industry that make it better than some of the older ones. So I just wanted to bring that up. I got a couple project profiles here. This is one where we had sandstone from early 1900s, and again, in terms of getting proper bids and quantifying what needs to be done, we did extensive elevations of this building, picked out certain stones. We ended up replacing about 20 to 25% of the sandstone pieces on this building. So you can kind of see the sporadic nature of what they took out and put back. Here's an example of the finish. One of the big issues they had was, again, de-icing salts and stuff around the entrances just ate that poor sandstone up. And so when we went back, we actually did some of the lower pieces replicated in precast and tried to power match that better so that it would stay up better. I put this in. These are all steel framed terracotta dormers on that building, and they also had little bands and gargoyles and stuff like that over here. This showed the extent of the backup rust and problems that they were having. And we actually had them take samples of all of these pieces, replicate them, and this was the replaced, rebuilt, finished dormer. Pretty proud of this project. Here's that new construction with the rain screen in Chicago. As I said, this was numerous different kinds of materials. Granite base here, you've got some metal panels that are between the curtain wall areas, and then you have like 3 different kinds of this. These are fiber cement panels that are basically just attached to a subframe over the top of the frame, insulated frame walls. I should say vapor barrier frame walls. So we were brought in on this one to basically be a professional check on the whole specifying submittal process and then partial construction. And I think the one thing I was going to bring up about this was, I think I got that in construction. This is a pretty typical project as far as you guys are concerned. Simple brick building, not real old, but the architect made one fatal decision, and that was to use these brick shapes as sills. Water sitting on them, staining, just blowing them up over time, cracking, that kind of thing. It just didn't last. I mean, there's a reason that, oftentimes stone sills, precast sills are used, and that's basically what we expect to have these building. This is the sort of concrete brutalist building. But what I wanted to point out here was this is like a 3-story curtain wall system that was at the front entrance of the library. And the original steel mullions in that curtain wall system were essentially gone down at grade level. Of course, as often happens, right behind the curtain wall in the 3rd story, there was the main server room for the library. So when you talk about things added later that cause you headaches when you go to actually fix something, that was one of the big ones on this.
How old is the building at that point?
This was probably early 70s, I want to say. So about 35 years old, I would say, when we touched it. And we went back with large format aluminum curtain wall tubes and basically just retrofitted it. I threw this in there because as part of the envelope, sometimes we don't think about it, but in this case, they're building a high school on a high water table site. And of course, the architect, I'm not sure why, but they decided to sink the building like a half a story into the ground as well, and put the gym and swimming pool on those at that level, at that half basement level. So with a high water table, we ended up specifying, and they're busy putting in blindside waterproofing. So when you think about the building envelope as a whole, basement comes into play, and this is basically a sheet membrane that is installed before the concrete ever gets poured. So it's attached to the forms, it's sealed, it's detailed, everything that may penetrate it has to be, pipes and whatever have to be properly detailed, and then they pour the slab or pour the swimming pool around it. So new construction, start of this. The new code requirement says that you have to have an air barrier on new construction. Now, an air barrier, generally you think of as going on the outside of a building, but there are 2 other flavors to that. There's also in the wall assembly, there's a vapor barrier, which should go on the warm side of the insulation. And there's a weather barrier that is what keeps the rain off the other components. There are times when that can be all one membrane. If it's located, in the case of a rain screen, for instance, the membrane is put over sheathing on open framing. The insulation is outboard as well as the cladding material. But that membrane is serving all 3 purposes, because water can get through the cladding, and the insulation layer also is in there but doesn't stop moisture. So water can get pushed all the way back to that membrane, which means it's a weather barrier. It's also the seal from that air pressure to keep that from, entering the building. And it's the warm side of the insulation, so it's also functioning as the vapor barrier from the inside out. So, depending on how your envelope, your wall system is constructed, you need all 3 of those components, and it may be 1, it may be 2, it may be 3 different layers of material, depending on where you're putting all the other components. In this case, this is open framing, the insulation is going to be behind it, they're taping and sealing all the joints. I believe this is getting a a metal panel system on the outside. In this case, we have the tilt up or just precast panels are pretty wedged. But these are also insulated on the inside. So when you're dealing with that, then all you're worried about is air and water penetrating from inside or outside. But you should have a paper material of some sort on the inside too, depending on what your interior environment is like. And it's my favorite current job. It's what happens when you let architects go wild. They have multiple materials, different structural configurations and appearances to make this facade really be lively. And it's a real challenge. This shows them trying to apply the membrane air barrier over the top of this sheathing, and it's about 10 degrees during the winter. Trying to get that to stick, trying to get it to fold and stay under these dormer soffits, things like that. You see the complexity, you got structural members sticking out here because it's a steel frame with block infill, and then multiple different cladding options. You've got a couple different kinds of brick. You've got this material called longboard, which is an aluminum extruded metal panel, but it looks like wood. It's got a printed wood grain to it. Then you've got obviously the windows in there, and I think there was one other component, but I can't remember what it was. So again, detailing connections and issues. Here we have, this is supposed to have a through-wall flashing for the masonry. This is a windowsill. This is the top of one of those dormers. You know, how's a guy supposed to flash that in? Who's responsible for this trade or that trade? You know, and getting that all done correctly. It's just incredibly complicated. And that brings me to commissioning, which is what people fall back on to say, we want one person that we can make responsible for all that stuff happening correctly and not having problems in the future. And they came up with this word commissioning to describe that. So we often get pulled in. In this case, this is that Illinois building. We've got a testing outfit that came in and basically mocked up a seal on the inside so that they could put a positive pressure on that, you know, well, essentially negative from the outside. Set up spray rigs and stuff like that. So they're basically trying to determine if the install of this exterior patio door was done correctly. We put, I think, about 20 pounds of pressure with the fans on the inside of it, spray water on the outside to simulate a storm condition, and hopefully it doesn't leak, but in this case, it did draw some water up right at the two corner sill lines, of